Hello guys, so I'm here to answer you all queries about diode. So as you can see in thumbnail, I have uploaded the datasheet of IN 4007. So I will answer you all queries. So hurry up guys, come on, please. Come on guys, please ask your queries. I am here to answer you, right? So guys, if you have any queries, feel free to write your queries. I will answer your queries. I will try to answer your queries. So I can see here two members are there. Uh, yes, Cruz D boss. So welcome, boss. So, what is a Jenner diode? So, this is, I think, this is very interesting question you have asked. So, Jenner, if you think about diode, has two characteristics. One is diode works in a forward region and diode works in a reverse bias region. The first one is diode works in a forward bias region and diode works in a reverse bias region. So what happened in the Jenner diode? Let us talk about the query of Cruz. What happened in Jenner diode? In Jenner diode, it works in a reverse bias region, right? So what happens is, let's say I'll be talking more about the practical experience. I will not talking about the copybook experience because you can go and find anywhere uh, about the Jenner diode. So what happens? Let us say you have selected a Jenner diode of 12 volt, right? So you have selected a Jenner diode of 12 volt. So if you apply Jenner diode works in a reverse breakdown region. The main characteristic of Jenner diode is if you have selected the Jenner diode of 12 volt, and if you are applying more than 12 volt across your Jenner diode. Let's say this is the Jenner diode. So if you are applying more than 12 volt across your Jenner diode, Jenner goes in the breakdown region and it works as a voltage regulator. So it limits the current and it regulates the voltage. Okay, so you can use Jenner diode. Yes, you have to use series limiting current limiting resistor before the Jenner diode, but at the end you can use Jenner diode with as a voltage regulator to generate the supply voltage of your circuit. So you have to make sure that your Jenner you are not drawing more current. Okay, so basically Jenner diode are used in the industry for drawing less than 100 milliampere current. Let's say for some application, your load current is 10 milliampere, 20 milliampere, 30 milliampere, or 50 milliampere, and you are trying to drive your small relay, like you want to drive your relay coil. Then on such application you can use Jenner diode. Okay, so one more thing you should note about that, Jenner diode is less stable. If you talk about the derating curve of Jenner diode, it is very less stable. It is less stable if you increase your temperature. Let's say your ambient temperature 25 degree, Jenner diode is more stable. And if you increase your temperature, ambient temperature more than 25 degree, it goes, let's say, 25 to 85 degree. So your Jenner diode becomes unstable. So this is the thing. This is the cons of the Jenner diode. So in place of Jenner diode, in such case, where you need to have your accurate system, you are looking for some accuracy, you can use some other shunt devices like TL431. So hope Cruz, I was able to answer your question. So you may comment here. You may comment here if I was able to answer your question. So hi Walid, I'm here to answer your question. You can ask anything about the diode. Okay, so I was discussing about the Cruz question about Jenner diode. So if you have some specific question, uh, yeah, yeah. Thanks, Cruz. I hope I was able to answer your question. Feel free to ask any further question if you have some further question. I'm here to help you guys, right? So this is my first live. I usually make a video and upload on YouTube. Now I thought to have to directly interact with you guys, and I might be share my experience and my knowledge with you. So if I talk about myself, I have 10 plus years of experience in hardware, product design and development. So I'm working as a hardware engineer in electronics. So my overall experience is like, if you talk about, so my overall experience about like gathering the customer requirement, generating, come up with the design, generate circuit design, PCB layout, circuit simulation, design calculation, design simulation, tolerance analysis, worst case analysis, then compliance testing like EMC testing and the product release. So that's what I do here. Yes. So Wally, do you have any specific question here? So come, yes. Okay, so Cruz again asking this question. I have seen types or know some diodes, but I don't know what they do, like photodiode, LED diode, and the laser diode. Okay, so yes, you are correct, Cruz. There are several types of diode available in the market, right? And every diode have some specific application, right? So let me talk about led is light emitting diode. So let's say you have some system, right? Let's say if I talk about the mobile system, you all have your mobile, right? So if you put your mobile on charging, you can see led. Okay, you can see leds blinking. So that is one application of led. In any application, let's say you have some some HMI, like human machine interface. You have your what I say, you have your refrigerator, you have your microwave oven. So all so in this application basically led is used. So how leds work? Led has basically three types of leds available, that is red, white and blue. And led has some forward voltage, that is vf, which is different for different type color type of led. Let's say for white color it is 2 volt. For uh, um, so RG there is a three basic color: red, green, and yellow. Yellow, I think. So if you apply for voltage across the LED, there is a forward current. Again, you need to have some series limiting resistor to limit the current. So what happens is LED, if you apply the voltage, led glows off, right? So this is one application of led. This is light emitting diode. So basically it is used for the indication purpose. If you want to indicate something by using your led, you can use led. Laser diode basically used in the medical devices, but for to be very frank, I haven't used a laser diode, and I also haven't used the photodiode, right? So these laser diode and photodiode have some specific application. And as I talk about, laser is used in the medical industry, but LED, light emitting diode, is most widely used in the industry. Okay, so if you want to know more further about how to design the LED, so let me tell you. Let's say you have 5 volt, right? You have 5 volt supply, and you want to drive your LED by using microcontroller with some specific to indicate some specific things or some specific application. So how will you design a LED? So the best practice is to design a circuit is like connect the 5 volt, then it has to go with the current limiting resistor again. And then the second node of current limiting resistor is to be connected to the LED anode, and LED cathode is connected one NPN transistor, and then you can connect the ground. So, and the base of the transistor you can drive with your base of the transistor you can drive with your microcontroller. So, Cruz, I hope I was able to answer your question. Okay. So, come on, guys. Feel free to comment. Feel free to ask anything. I think Cruz also left the live session. Okay. So, I think nobody is in live, and uh, still I'm waiting for some question you guys ask about the the diode, specific diode. If there is a no further question, what I will do, okay, so I know the video is about diodes, but I can ask about transistor. Yes, Cruz, you are feel free to ask about the transistor. I'm here to help you. So I'm here to help you. Please ask your question. Feel free to ask your question about the transistor. Guys, you haven't liked this live, please press your like thumb. So that's what I appreciate you. So I think there is only one like I can see here. Okay, so again I got one more question from Cruz. So uh, I don't know how much about them. Do they really do the function? Okay, so I hope you're talking about the transistor. So let me explain a bit about the transistor. So basically transistor is a different type, like it is BJT, bipolar junction transistor. It is also MOSFET, metal oxide field effect transistor, and you also maybe know about the IGBT, that is insulated gate, okay, base transistor. So I will talk about now BJT, an application of BJT, how BJT is being used, mostly used in the industry. So there is basically two application of BJT, right? There is two application of BJT. First one is BJT is used as a switch. So 90 around 70 to 80% industry used BJT as a switch. And the second application of BJT is amplifier, which is used in some cases, right? Which is used some cases. So let me talk about how BJT is used as a switch. Okay. So if you want to use BJT as a switch, what happens is you have to there is a three modes of BJT which BJT operates. One is like cutoff mode. If you see the IC versus VCE characteristic of the BJT, you may go and see the data set. I'll tell you the part number. The part number is BC547, right? BC547. And if you go and see the data sheet and analyze the all parameters of VJT, right? Analyze all parameters of VJT. So if you see the plot between IC and VCE, there is a plot between IC and VCE. So there is a three modes of VJT. One is cutoff mode, and other one is active mode, and the third one is a saturation mode. Okay, so if you want to use BJT as a switch, you have to use BJT in a saturation mode. Okay, how saturation mode works? Saturation mode means if you apply more current on the base of that BJT, even then your collector current will not increase. So hope you are trying to connect what I'm saying. This is very important, Cruz. So if you apply more base current to the BJT, your collector current won't increase. That means your BJT is now in saturation region. If you are when your BJT in saturation region, you can be use BJT as a switch. It has either on state, and it has either on state, or it has or off state. So what happens? The application, what is the application? So let me try to connect. You can drive by BJT you can drive your relay as well. So let me say, if you want to drive your relay coil with the BJT, how will you drive? Let's say your relay rating is 12 volt. Connect relay one connection to the 12 volt VCC rail, and other one is the collector. The collector of the collector of the BJT, and the emitter of your BJT is grounded. Now you can control your base of the BJT through microcontroller. Make sure that you have to limit the base current. If you apply more current to your base, your BJT may got damaged, and you can see there is some smoke coming from your BJT. So you have to design the base resistance, right? Like RB. You can say the in BJT there is two resistance. One is RB, one is RC. So in place of RC, you can connect your relay coil, and in place of RB uh, you have to design your RB in a such a manner your transistor won't get damaged. And there is a one relation between IB and IC. So your IC equals to beta times of IB, right? Your IC equals to beta times of your IB. So what happens is, if your base current is in microampere and your HFE, if you go and look at the data sheet of the transistor BJT, there is a one parameter called HFE, and if you apply 1 microampere at the base and your HFE is 100, so you can get maximum current to the collector is 100 milliampere, right? Likewise, so likewise you can calculate your IC equals to beta into IB. Okay, so hope Cruz I was able to somehow answer your queries. Any further question, guys? Yep. So meantime you I was speaking in standalone where meantime you can comment if you are listening me. If you have some question, further type me. I'm here. Maybe another for 3 minutes, 3 to 5 minutes more to answer your queries. If you guys really want to come live, me you can comment. So make sure at least once in a week I'll come live and I'll meet you people. Right. So this is personally very interesting to me. Yes. Okay, so Cruz is now saying, yes, thanks. When will be another live since I am leaving? Okay, I'll update. Maybe I can say tomorrow I will try to come, otherwise next week. So usually I work for 5 days, so maybe I'll come live in the weekend. So thanks, Cruz, for coming. Thanks for your question. So a very good question you asked about. So I encourage you, please don't limit yourself. Keep on learning. Good luck, Cruz. Bye bye. So I think I can see here one people also connected. So any question, I don't see your name. So if you can comment, I can see your name here. And if you have some further specific question, you can ask me. Okay, guys, please like, share this live stream. Please, I can see only 2 like here. So please like, guys. If you have any question, feel free to ask me here. I'm here to answer your all queries about Diode today. So maybe I'll be here for another 1 or 2 minutes. So I can see here two people is seeing this live stream, but there is a no question here. Any further question, guys? Feel free to ask me any further question. It's all about you. Let me, if there is a no question, let me walk through you the diode data sheet IN4007, right? IN4007. So if you go and look the data sheet of IN4007, there is a specific rating written here like maximum repetitive peak reverse voltage is 1000 volt, maximum RMS voltage is 700 volt, maximum DC blocking voltage is 100 volt, and the average rectified current at 75 degree. This is very interesting. Is 1 ampere, and peak forward surge current is 30 ampere, and non-repetitive peak forward current is 45. Okay, so you can see the operating temperature is minus 50 to 150, right? I to T rating, that is rating for fuse, is 3.7 ampere second. Okay, and you can also find the forward voltage is 1.1 volt. Okay, so by doing this, you can go and analyze the data sheet of IN 4007. The rating and characteristic you can see here, the curve like average rectified current between the forward current derating curve. You can see here in the data sheet at 75 degree, your forward current derate. If you go for like 125 degree, and your forward current will remain around 300 milliampere. Okay, so any question, further question, guys? No. So I think only two people are still there. Please like this live. So see you soon, guys. I'm ending this live stream now. See you soon. Bye bye.